Okay, we're going. Great.
It's just us.
Huh?
It's just us.
Yeah, it's just us. I don't, whatever, I can't even remember their names. Stephanie has something going on, and then Teresa couldn't get off of work.
Okay. Yeah, I just literally logged on because I've been at work all day, so.
Okay. Did you go over it? I did the preparation assignment, and I looked at the group assignment, and I kind of did that one, but have you done the, have you looked at anything?
Yeah, I did. I looked at the preparation. How do you look at the, what do you mean the group?
You know, there's the part 1 and the part 2. We're supposed to do part 2 as a group.
Right.
I did. Yeah. So after our poor performance last week,
yeah.
I figure we can just do what we did last week and just jump straight to the group quiz.
Right. So it doesn't take like 2 hours.
Yeah. I feel like we've figured out, we've hit our stride.
Yeah.
We can just do straight to that, and then I tried to get the answers for us from Stephanie, but she wouldn't do it. I was like, don't tell us that you took the quiz and you're not going to tell us.
Did she take the quiz?
She said she took the quiz, but I asked her, I said, you could give us the answers, and I was like, I'm only partially kidding, but I'm not really at all. You should really give us the answers. But she didn't say anything back. So I think that, like, I don't know, people must not check their email like I do or something, because I don't know. You're supposed to help out your group. If you're going to take it beforehand, you give the answers.
I have a 93 now because of that B last week and that on that test or whatever.
I'm not going to lie, and it's the worst grade I've ever gotten since I started at BYU. I took one of my homework quizzes on like 0 sleep. I mean, I went like 32 hours without any sleep, and I got a 70% on it. I've never gotten a grade that bad, but it dropped me down to a 90, and I was like, okay, well.
I know, and I didn't think it was worth that much.
I didn't either, so I didn't really look over everything else, so I'm going to see what his like drop thing is. I was tired, and like, I don't think that counts. But like, I still have an A. It's going to be an A no matter what. I mean, even if it goes down to a B at one point, you get it up doing other crap. So. Right,
because I think the exams are like 60% of our grade, which is like a lot. So.
Correct. So yeah, when it comes to the exam, I'm not real worried about it. I score really well on exams. So.
Yeah.
Okay. Let's go straight to the.
So lesson 4 group meeting, right?
Yes.
Okay.
I completed the individual preparation. True. I actively participated. True. We are here. Okay.
Well, there's not that many. Oh, well. I guess it's the same amount as last week. It just doesn't look that bad.
No. Is it as many questions? Maybe a little bit more.
13. Might be one more. Not sure.
What is the probability that a randomly selected person in the United States has type O blood? How many blood types are there? O positive.
Which one are you on?
Number 4? No, number 3. Oh, wait. I see. There's a table.
Yeah, I was like, wait.
I didn't see the table. I had scrolled down too far. I worked last night. I still haven't slept yet. So.
Where do you work?
Right? Huh?
Where do you work?
I work for the sheriff's office, law enforcement.
Oh,
so.
That's awesome.
Yeah, I'm tired, but not too tired.
Yeah, I work at a credit union, so I'm like surrounded by numbers all day.
Well, great. We should get.
Oh, yeah.
All right. Give all your probability answers as decimals, for example, blah, blah, blah. Human blood can be classified into one of 4 basic types, O, A, B, A, B. The portion of people in the population in the United States with each of these blood types is summarized in the following table. What's your blood type?
I have no idea. Isn't that bad?
That's super bad. Yeah. At the sheriff's office, we have to know our blood type, and we have to keep it on our ID card. We have to keep the special ID card, and it has to have our blood type on there.
Really? Well, I'm definitely not O.
Just in case we die. So. All right. Blood type proportion. The blood types and the proportions given in the table above. Distribution. What the freak? I just did this last night, and I don't even understand. Probability distribution is 1, right?
What is it?
It's just 1. Like, hold on. Like, it's evenly distributed over.
Right.
Distributions for short. Possibilities follow a pattern. Probabilities cannot be negative. There's no negatives.
Right.
They cannot be larger than 1. Does that equal up to 1? 45, that's 85, 96, 100. So that's step 2 is good. Probability don't. Number 3, step 3, probabilities don't add up to 1. That doesn't make any sense. Or 100%. Probability that he does not finish his homework is actually 1 minus the probability that he will finish his homework. What? Step 3. Do you see that?
Yeah. The probability that an event X will not occur is 1 minus the probability that it will occur.
This is asking the blood types and the proportions given in the table above to find a probability distribution. So
I mean, I think it's true, but I don't know.
I think it's true. It's step 3 is kind of tripping me up a little bit.
I know.
It says probabilities cannot be larger than 1. Okay. But probability don't add up to 1 or 100%.
I'm looking up complement rule. Because I don't. Is it on there?
Mm-mm. I'm gonna pull up my my notes because step 3, I feel like they gave us more examples on step 3. So I'm wondering if are you looking at the
Complement rule?
yeah.
So do they have to complement each other? Is that what it's saying?
I don't know, I'm scrolling down real quick. The probability that event X will not occur is 1 minus that it will occur. See, this is confusing to me because it's not adding up. It's just it's asking for is the proportion of people in the population of the United States with each of these blood types is summarized. So it's asking for proportion, not really probability more than anything.
I think it's true.
It's true. I mean, it has to be true.
Yeah.
Okay, well, we're moving on then.
Yeah.
What is the probability?
Because all the probabilities, they're all between 0 and 1, and it all equals 1 together. So
yeah.
Okay.
Yeah. Okay. What is the probability that a randomly selected person in the United States is type O blood round to 2 decimal places? Is it 0.45?
Is that what we do? We don't like multiply them all together and then.
Type blood. What is the probability that we multiply them all together?
I don't know. That's.
Let me think about this. This is like, is this like discrete?
Look at on the textbook, look at 2.2, and that says probability notion. Is that what we do? Like.
Well, that's what I was thinking.
It's still 0.45 if it's over 1.
It'd be 1/4?
Would I do 0.45 divided by 1? Since it all equals 1?
Let's try it.
Because that's 0.45.
Is that what it says?
Yeah. I don't know.
This is really confusing.
Well, it has a randomness, 2.4.
Yeah, What is the probability that a randomly selected person in the United States has type O blood? Would we divide? This is my problem. Like if you divided by, if you had all 4 and you did 1 divided by 4, like 1/4.
Yeah.
You get 0.25. It's kind of like the 41 men on a ship thing from the homework.
Yeah.
Where you did the 1 divided by 41. Like, what was the possibility that you would draw the stone with the X or whatever marked on it?
Yeah.
They put them all in the bag, and then one person out of 1 out of 41, and the possibility of that was 0.0244. So, but in this, the 0.0244, this is about 2%. Oh, they want us to keep it in decimals. So is it 0.25?
I guess. That sounds right, I guess.
To me, that sounds right. Then it says, what is the probability that a randomly selected person will not have type O blood? That's 3 out of 4. This is 0.75. It's 0.75.
That's the 0.25. That equals 1. So, yeah.
That seems too easy. Whatever. I don't know. Okay. Caroline Willis and her colleagues conducted a study in which dogs were trained to detect bladder cancer. The dogs were trained to lie down next to a specimen derived from bladder cancer patient. Tangle, one of the dogs, demonstrates the identification of a specimen. 7 bowls contain urine were lined up in a random order. 6 of the samples were from patients who do not have bladder cancer. One of the samples came from a person identified as a bladder cancer patient. Answer the following questions. If the dogs guess at random, what is the probability that they will correctly identify the dish containing the specimen from the bladder cancer patient?
Oh gosh. So 7 bowls containing urine were lined up. 6 of them were from patients who did not. So only 1 bowl has cancer.
Correct. So 1 divided, what is that? See.
Is it 1 divided by 6 or 7?
1 divided by 7. 6 of the samples from patients who did not have it. That gives you, I don't know if can you see that? Is it backward?
1.42, pretty much 3.
So rounded to 3 decimals, it'd be 0.143.
Yeah.
This feels like it's too easy.
I know.
There's no way that I'm this advanced in statistics to be able to be like, yeah, this is what we're doing. I feel like there's a trick.
I know. I'm nervous, especially after last week. Last week was so difficult.
Yeah. Everyone like tells me, they're like, statistics is so hard. I'm like, oh, this is making me mad. Okay. Combined total of 54 trials, the dog correctly identified the specimen from the cancer patient 22 times. It is very unlikely that the dog did do this well by random chance alone. What if that the dog would do this well by random chance alone? Which of the following statements is most appropriate? This provides strong evidence that dogs can detect bladder cancer. There's little evidence that dogs can detect bladder cancer. It's 50%. No, it's less than 50%.
Yeah, it's less than.
What's the, isn't there a rule about that? Divided by 54. That's 0.40. It's that's less than 50%. I don't feel like, I don't know. If dogs detecting 40% of bladder cancer, like, to me, that'd be cool. I'd be like, yeah, that's enough. What do I know, though?
I know. So how many times out of 54 it got it 22 times?
22 times, that equals 0.4074. So I'm going to look really quickly and see if there's some sort of rule. The probability that x is a number between 0 plus 1. Huh. Is it that easy? This is like, hold on, I gotta read. See if you can see anything about like a percentage, being like a rule, like it has to be between such and such.
Okay.
An answer to a problem, a student reported the probability of finding life on Mars is 0.35. What is wrong about the statement? Well, it's a negative. Okay. Randomness. It had to be under randomness.
It doesn't really have a formula for randomness.
No. It is not haphazard, but pattern. Any random process follows a very distinct pattern over time, the distribution of its outcomes. For example, if you realize about 1/6 of the time you roll before. We can be sure that it follows a long-term pattern, its distribution. We can never know that the outcome of the next experiment will be. So
I guess little evidence.
There's little evidence. M&Ms are, I couldn't pick a bladder cancer bowl out.
Yeah.
I don't know. Maybe the pee smells dirty. I don't know. M&Ms are small chocolate candies. M&M website previously indicated that in the United States, the distribution of the colors in a bag of plain M&Ms is given in the following table. If you reach in the bag of plain M&Ms, what is the probability of drawing a red colored candy?
Okay. Isn't this where you multiply them all together?
Yeah. But is it like this setup? Hold on, let's see if you can see it. This one right here.
Hold on, let me find. Yeah.
So then. So then it would be. Would it be 1 times 0.13? Plus 2 times 0.14 plus 3 times 0.13.
Let me. Because I was in Math 108 last semester.
I was too.
And we did do probability, but I can't remember it for some reason. We had a question like this.
I tried to block it out.
Yeah.
And then green we don't know, but it's still there. 1, 2, 3, 4, 5, 6. Let me go get my notebook. I think I took notes. I'm just old school enough that I keep everything in a notebook.
I do too.
Okay. Oof. All right. I thought I would never have to use this crap again. Oh man.
I know, I've kept all my stuff too.
Well, they said that. They said you should keep all of your notebooks because you never know. When I started this semester, my notes looked like in Math 108. They looked pristine. They were very pretty.
Yeah.
They looked like I'll show you what they look like. They looked like this. This is how I started the semester in Math 108. And it ended. I got so sick of it. It ended like this.
Yeah, me too.
Like little scratches on there. So we did probability towards the end of the semester. Who was your teacher?
Brazier.
Oh.
Was a guy.
Yeah, I don't remember who I had.
He didn't it was weird because he didn't teach anything.
Mine didn't either, not at all. Everything was off the PowerPoint.
Yeah, same.
Statistical reasoning. Sometimes when I really don't know, I just highlight everything and I search Google.
I do too.
Sometimes
I'm doing it now.
Do you see anything?
For some reason, no. With that, I'm gonna look again. Like, it's not showing me. Do we add all of them up and then divide by how many reds there are?
You can try it.
So don't count green at all, right? Since it's scratched out.
That's 0.84.
And then divide by 0.13.
Is there no green? Or are they just trying to...
Yeah, I guess just don't even. That doesn't make sense. If you divide it, 0.84 divided by 0.13, you get 6.46.
I got two different answers. When you divide 0.84 divided by 6, that's including green, you get 0.14. When you divide it by 5, you get 0.168. It's like Spanish. I don't understand any of this. Okay. I know in statistics, what the stuff we learned last year, it was like the probability that all 3 chocolates are milk chocolates, you know?
Yeah.
You would do, like, let's say it's, well, it's right. Can you see it's my chicken scratch right here? It says, like, it gave us, I think it's like 3 chocolates. It's backwards. 8 dark chocolates, 12 milk chocolates, and then it starts down here, 12 divided by 20,
yeah.
11 over 19.
Look at the next one down. It talks about green, but it's scratched out.
Well, that's the thing. What is the probability that a randomly selected candy is green? When you add them all up, it's 0.84. So if it's out of 1, you would take like 1 divided by, or 1 minus 0.84, which is 0.16. Does that make sense to you?
So it's 0.16?
Yeah, for 9. What is the probability
that
that
doesn't make sense, but I don't understand number 8.
I know. What is the probability that a randomly selected candy is not green? Well, that's 0.84. We'll come back to that.
Okay.
The ACT scores of students admitted to a medium-sized public university in the Western United States were taken from the capex.com. The following summary statistics were calculated. Use the information from the public university to answer the following questions. Half of the observations are less than equal to what number?
Review.
Did they teach us this?
I don't remember reading this. Would this be under
This is towards the I'm in the wrong textbook. They don't prepare us for the fact that nobody teaches you. I think that a real degree is online because no one teaches you anything.
Yes. I'm trying to like find it, like you know how you.
Yeah. I'm going down in the textbook right now to see if there's anything that might help us out. Boy. Let's see if anyone posted anything about this being ridiculously hard. Video link. What's the video link? Homework.
Oh my gosh, this is hard.
I'm gonna watch the video.
Okay.
The math department, and I'll be covering lesson 4, which is doing.
I can hear it, so.
Discrete random variable. So first of all, I want to talk about this well.
Blood types.
Getting brown eyes. There is brown is the dominant gene, so that depending on the genetics from the family, there's probabilities going.
Okay, let's get to the blood type part.
Must equal 1. And then finally, if E represents an event, and PE is a probability of that event, then the
Can you hear it?
that event
Yeah.
happening is 1 minus PE. So that's called the complement rule. Okay. So now here's the 3 probability rules again. So let me just go through this. I'm going to expand the slide here. And here is 3 rules of probability. So example 1, here's the probability of the number of heads from 2 flips. So event 0 represents 0 heads. The probability of that is 25%. 1 head is 50%, and 2 heads is 15%. So based on these rules of probability, is this a probability model? Well, I kind of fooled some of you a little bit on this. It is not a true probability model because the second rule does not apply. The sum of all probabilities does not equal 1. However, if we change this up to where the probability of getting 2 heads is 25%, then this would be a true probability model. And here's the possible outcomes. You can get heads first, or heads second, or you can get 2 tails. Okay, so or no heads. So this is a true probability model because the first 2 rules of probability apply. All these probabilities are greater than 0 or
so
less.
That first one was definitely true.
Yeah.
Then, so let me just skip this to the next part here. So here, another example is the probability. Now, for instance, here we have the probability of getting a certain color in an M&M bag. So the probability of red being 10%, green 10%, blue 10%, yellow 20%, orange 30%.
Do you have? I'm going to pause this real quick. Do you have the numbers written down that we're working with, like the green?
I can write them down really quick. I have them up on the screen.
Write them down, like real quick. I don't have them. Let me see if I can write this down real quick. That way, as he's explaining it, we can do it at the same time.
Yeah.
And hopefully, let's see.
So do I just write 0 for green?
Yeah. I mean, don't write anything. Just leave it blank.
Okay. All right, I'm ready whenever.
0.20. Green is blank. All right. Let me go back to the video.
Now here's the question mark. So the first question is, what's the probability of drawing a brown M&M using the rules of probability? Well, if we sum these up to make this 0.2 plus 0.3 plus these 3.1s, we get 0.8. So the
this is 0.4, right?
0.2.
Yeah.
All right.
The one that we can't figure out. The one that's like.
It all adds up to 0.84 though, right?
Yeah.
Okay. We need to know that. Is that what he's saying?
Huh?
He's saying to like add all of them up first or no?
Yeah.
Okay.
So when he's doing, we're number 8 that we can't answer, that's what he's doing right now.
Okay.
What's the probability of not drawing a brown M&M? In this case, it would be 0.8. Okay. What's the probability of not drawing a yellow M&M? Well, yellow is 0.2, so the probability of not drawing a yellow would be also 0.8. Okay. And so here's another example. Number of girls with 3. What's the probability?
Whoa, we missed that.
So
yeah, I'm confused.
Going back to the brown one.
0.8,
Okay.
10%, green 10%, blue 10%, yellow 20%, orange 30%. But we don't have brown here. It's a question mark. So the first question is, what's the probability of drawing a brown M&M? Just girls' probability. Well, if we sum these up to make this 0.2 plus 0.3 plus these 3.1s, we get 0.8. So the probability of drawing a brown M&M is 0.2. What's the probability of not drawing a brown M&M? In this case, it would be 0.8. Okay. What's the probability of not drawing a yellow M&M? Well, yellow is 0.2, so the probability of not drawing a yellow would be also 0.8. Okay. And so here's number.
So this is kind of confusing because we don't have.
It doesn't equal 1.
Right, we don't have green, which is our problem. So when I ask what's the probability of drawing red, if we equal it all up.
So I guess however he found yellow in that video, that's how we'll find red. Because they don't have brown.
How he found it is he took it out of 100. So I'm guessing that we're assuming it's 100. And then he out of 100 and he subtracted. That's of not drawing yellow.
Yeah.
And we're trying to draw
red.
Yeah. I give up. I don't give up. I mean, I'm going to finish this.
Whoa.
I just got done at the gym and I smell really bad. I know. I feel like I give you guys TMI like every single time, but sometimes I feel that's the only way to break the ice because everyone has to feel like they're not alone. Like, I'm not alone.
Yeah.
That's what I do. But, so that's my number one concern is getting in the shower, but then it's the homework. If you reach into a bag of plain M&Ms, what is the probability of drawing a red colored candy? Isn't it 0.13? That's the proportion. That's the proportion. So.
Okay, do this. 0.84 divided by 0.13. Does that make sense?
Well, because if you look at value times proportion, this is in the looking at standard deviation, but the probability that an outcome will not occur is 1 minus the probability that it will occur. So you said 0.84 divided by 0.13?
Yeah, it doesn't make sense to me, but how is that a whole number?
Because you have to multiply it. It's decimals.
Oh.
You get 0.1092. Why are we dividing it?
I meant multiply. I don't know. I'm confused. Like, I feel like this is so simple, but I'm just not.
Let me go back to the video.
Ability of getting girls. So for instance, here is the note. So say for instance, getting a boy or a girl at each birth is equal, assuming that they're equal. And here's the probabilities of the number. So the probability of the number of girls being 0 is 1/8. 1 girl is 3/8. 2 girls is a question mark. And 3 girls is 1/8. So based on the rules of probability, what's the probability of getting exactly 2 girls? Well, looking at this, if we take these numbers and we sum these numbers without the question mark, we get 5/8. So then what's left over would be 3/8. So what's the probability of not getting exactly 2 girls?
So it sounds to me like we have to add it up over 100.
So we would take the 1 minus 3/8, and we would get 5/8.
Because it all adds up to 1.
So just assume that it's 100. So the green will be the filler.
What is the probability of getting a red? Oh my gosh. It shouldn't be this hard. What does Google say? Anything?
I'm still looking.
Okay, let's pause for a second. Copy. This isn't cheating. This is educating ourselves further.
Yes.
Okay, I'm going to share my screen really quickly and just show you what I saw.
Okay, 1 second. Let me add this up.
Okay. Oh, wait. Nope, wrong one. Wrong screen. Wrong screen.
Yeah, I think it has to equal 100, so.
So, where did I find this?
Yeah, I just clicked on that too.
So, what is the probability of drawing a yellow candy? 0.1, because that's what it all adds up to. Of not drawing a red candy, 0.7. So, to me, out of 100, it has to equal 0.13. But
yeah. So the next two would be different.
Yeah.
If it's out of 100.
So 0.13. So what is the probability that a random selected candy is green? All of that, when you add it all up, the numbers that we have, it's 0.84.
Right.
And 1 minus 0.84 is still 0.16.
Yeah, okay.
What is the probability that a randomly selected candy is not green? We already know it's 0.84.
Yeah. I hate filling in the blank.
I hate them too. Okay. Half of the observations. Do you want to read that part real quick?
Yeah. Number 11.
Yeah, I'm listening.
Okay. The ACT scores of students admitted to a medium-sized public university in the western United States were taken from capex.com. The following summary statistics were calculated. And then it has a graph. And it says, use the information from the public university to answer the following questions. Half of the observations are less than or equal to what number?
So, half are equal to. It's an equal to what number? Half of the
review, meaning we should know how to do this.
That's review. That's the median. So, what observations are less than or equal to what number? Wait, is it mean? Is mean?
I'm gonna.
Oh, I'm only slightly frustrated, just slightly.
Oh, getting there.
So half would be what the middle number is. Is that the median or the mean?
Median's middle.
So that would be half of the observations are less than or equal to what number? That would be 24, correct?
Yeah. I guess. I don't remember. I don't see this in the text at all.
It's not from this week, it's from last week.
Oh, is that why it says review?
Yeah. Based on the information on the table above, the top 25% of the students scored above what number?
Are those numbers supposed to be percentages? No.
I mean, we can assume.
No, definitely not. Because the mean and stuff wouldn't be a percentage.
The top 25% students scored above what number? That would be
Maximum? Would it be 35?
based on the information on the table, the top 25% that would be like.
Remember like the quartiles and stuff?
That's what I was looking at, the quartiles. Quartile 1 would be 25%. And then.
Is that maximum or does it not say? Does it not say?
Well, they scored above a 22. Because that's quartile 1 is 22. So you have 0%, which is your minimum. 25% is your Q1. Your median is 50%. Your Q3 is 75%. Your maximum is the highest number. So if we're going the top 25 students, that would be 0.75%, right?
Yeah.
So that would be 27.
So 27.
Yeah. Because that would be the Q3. Did you see that?
Yeah. Yeah.
Which of following statements is not one of the 3 rules of probability? We can do this one. I am for sure about this one. All right. A probability is a number between 0 and 1. So, okay, so that's on there. The probability that an outcome will not occur is 1 minus the probability. That's number 3. If the probability is high, then the sum of the probabilities, any probability is 1. So it is, and the probability is high, then probability is positive. If the probability is low, then the probability is negative. So do you see that one?
So it's that one. Yeah. See?
Yeah.
Pretty much.
Should we review all these one more time, see if our knowledge has changed at all?
So not the first 2 because that's
pretty easy.
And 3 is, I think that's right.
You think that's right?
Yeah.
What is the probability that a random selected person in the United States has type O blood? Let's watch this video a little bit more.
Also, no more than 1 girl. So what we could do is that we would, so it's 1 girl, but you can also include 0 girls. So it'd be 1/8 plus 3/8, which would be 4/8, which is also equal to 1/2. Okay, so those are the basic rules of probability. And so the next item I want to mention is dealing with the discrete random variable. Okay, getting the mean and the variance of a discrete random variable.
That's this,
now,
yeah?
This is the formula for it, basically. So for instance, if the event is X, probability is P. And we have, here's the possibilities of the event, 0 heads, 1 heads, 2 heads. And then the probabilities associated with those, 0.25, 0.5, and 0.25. What we can do is that we can take 0. Here's an example of this. We can take 0 times 0.25 and multiply those together, plus 1 times 0.5, okay, and multiply those two together, plus 2 times 0.25, and we multiply those two together. Then we take all these multiplications together, we add them all together, and we get the answer of 1. That would be an example of how to get the mean of a discrete random variable. In order for us to get the variance, here's the formula for it. But instead of talking through this formula, let me just give you an example using this problem right here. So what we would do is that now that we have the mean, this is the formula for it, where we would take 0 heads minus the mean, which is 1, and we would square that, okay? And then we times it by the probability of that event happening, 0.25, plus, and then we would take 1 minus the mean, which is 1, okay? This is the mean here, and we square that, and then we times it by 0.5, okay, which is the probability of that event happening. Plus, and then we take the event of 2 heads, which is 2, minus the mean, which is 1, and then we square that, and then we times it by 0.25, which is the probability of that event happening. And then we add up all those together, 0.2. So we add up everything here. We
don't need the variance, right?
Plus
No.
here plus the multiplication here. We add all those up, and we get a variance of 0.5. Okay. Now to get the standard deviation, all we have to do, and this is basically what we learned from lesson 3, we take the variance, we take the square root of that, and we get the variance, which is 0.707. Okay. So now what we're going to do is we'll have you use Excel to compute the mean, variance, and standard deviation of a discrete random variable. And let me just go through an example of that, of how you can do that. This is an iLearn. You can get this in iLearn. And so say, for instance, if you have events 0, 1, and 2, so 0 heads, 1 head, and 2 heads. And the probability of those would be, for each of those, let me just go back to this here, the probability of 0 heads is 0.25. And then the probability of 1 head, which is 0.5, or just only 1 head. And the probability of 2 heads would be 0.25. Then everything is calculated for you, where you get the mean is 1, the variance is 0.5, and the standard deviation is 0.707. Okay, and that matches what we have here on this slide. So you can use this to calculate the mean, the variance, and the standard deviation of a discrete random variable. And that concludes the video for lesson 4.
Thanks for not teaching us anything, guys.
You're one of your TAs.
That's okay. Stop. What that allowed me to do is have time to change my clothes. All right.
So does that look right?
Yeah. The 0.143, that makes sense because we rounded to 3 decimal places. Well, Grayson, should we just do it?
I guess.
I guess it's my turn, right?
Yeah.
Do it, dude. 80%. It's not bad.
No,
Okay.
that's not.
Considering, okay, so 4 and 5 were wrong.
Okay. Is that it?
7 was wrong, so there's strong evidence. We got 8, 9, and 10 right. So the only ones we missed were 7, 4, and 5. We're doing pretty good.
Yeah. So by ourselves.
Yeah. So I don't know what to say about 4 and 5. What is the probability the random selected person in the United States has type O blood?
It all equals 1.
So I would say that would be 0.45.
What did we put? 0.25?
Yeah. Will not have.
Would it be 0.55 for number 5?
Yeah.
Wait. All right, I'll just put that.
Don't forget to change 7.
That's what it is.
Dang it.
Yeah.
Oh well. You win some, you lose some. At least
Hopefully my grade went up.
did it go up?
Look, hold on.
Mine definitely went down.
I
I have an
it
80.
went up.
I have an
Yeah, it went up 1.
89.01. It's okay. I'm not too worried about it. All
I'm
right.
nervous about the test, but oh well.
Yeah. So, okay. Well, we did it. So that's that. I will post a thing, and then we'll meet on Thursday, and we'll be just as prepared as we are now, which is not really at all, but at least we kind of did it.
Wait, so what time Thursday?
12:30. Is that what time are we normally starting? I don't really know.
I don't know. It doesn't matter.
12:30 is fine with me.
Okay.
Now hold on. We're supposed to sign up to meet with the TA.
Oh, we are sign up? I thought they just randomly.
Apparently we're supposed to sign up. Teresa sent me an email. I'll forward it to you so you can see it.
Okay.
I guess we're supposed to sign up, but any of the day, like the only thing I can think of is like on Friday, like a Friday during the day, if Teresa's schedule we can work on it and stuff, because that's really her only really available day. So I'll forward you the email so you can look at it.
Okay.
And then we can kind of go from there. I haven't signed us up yet because I didn't feel comfortable signing us up without talking to everybody.
Right. Okay, Friday during the day should work. I don't work on Fridays, so.
I don't work Fridays either. So I will send that to you, and then you can look at it.
Okay.
Cool. All right. I will see you Thursday.
Yeah, see ya.
Bye.